this teaching unit, which is called Adopted Tree, and it is designed to raise awareness about trees, especially in urban environments, because they are so much neglected. As an Erasmus plus KA1 project trainer, I always ask the trainees to draw something, to give me a description of what they have seen while walking from their hotel to the venue, and they always draw some building or a car or some other people and or shops, and they always fail to draw a tree. It's like there were no trees between the hotel and the venue. Anyway, so the first part is devoted to the Green Kingdom, uh, which, to my surprise, has a very complex biology. So when maybe I underestimated the level I had to deal with it, and the trees and the plants in general can communicate with each other using mechanism using fungi under the ground. Second part of the teaching unit is uh, devoted to voltage, because voltage is everywhere. Even if you touch the terminals of a multimeter with your hands, there will be some voltage, maybe a few millivolts, but it's still there. And as far as plants are considered, I will explain how this voltage is produced. And the third part is actually what we call Internet of Trees. And we had Corina and I had two different approaches to the same problem. We used a lot of electronics. We made well, a little bit complicated devices, but our students were very excited, and our upper secondary school students were very excited, and they did a lot of things, if not all, by themselves. The first part of the experiments is about photosynthesis, and to visualize the oxygen, the carbon dioxide and the oxygen that are involved in this process. We used a water plant. At the beginning, we made a solution of baking soda and water, and we can, after a while, when the solution is totally transparent, we can see very tiny bubbles of carbon dioxide moving upwards, while the oxygen bubbles that are formed, especially near the cut stems of a water plant, are a lot bigger, and of course, there are not so many. Water plant like the one I show has a very small cost of something like 2 or 3 euros for a big plant that you can put in your aquarium. So I will move forward this video, because you can actually watch it either on Science on Stage Europe website or on their YouTube channel. So this solution is water with baking soda. As you can see, it's clear, and now you cannot see any bubbles at this moment. And then we put it in a strong light source, and you can see the oxygen bubbles forming. After this experiment, I will explain later how everything is connected, because how everything is connected to the voltage production. Well, second is transpiration in a jar, where we can actually use a small plant which is will we are going to have some water uptake from a small jar, and we are going to put everything in a bigger jar and put it near a light source again, or we can just leave it in our room. And in every video, we use time-lapse software, which is really impressive because you can actually see the plant moving. Because we think that plants are just they never move, but here you can see the leaves that try to uh, orient themselves according to the light source. And of course, you can see a lot of water vapor, which turns into water on the walls of the jar. Then it is about stomata and vascular tissue. Another experiment with a big leaf that actually, if we make an airtight jar and we suck some air from a paper straw, then there will be we will see some bubbles coming from the stem of this leaf. And if we want to be sure that these are because of the leaf, we can just smear some petroleum jelly on the underside of the leaf. So we block the stomata, and then we cannot see any bubbles like you see here. And that means that stomata are placed under the leaf, and they facilitate the transfer of gases. This is another experiment which is also very impressive for at least for our students. We use Chinese cabbage. Well, maybe I have found it with different names, but you will see what I mean. I have cut 3 different pieces, and of course, at the beginning, they are almost off white, a very light green, but they turn yellow, green, and red because they absorb the this is actually a food grade dye. And this is another experiment, and with the same plant, and you can see that it moves. Of course, time lapse is something like one frame every 1 minute or something. And this is a very useful device, and especially for primary, because you can actually make a photometer. This is the Greek name for transpirometer. You can actually measure the transpiration rate. And what was impressive was that, for example, EROS students found that the transpiration rate was almost the same during the night. So that means that the plants, because of the temperature rise, which is due to climate change, are stressed even at night. So they need water to cool themselves. And we put some oil to avoid the evaporation of the water, and a ruler. So every let's say 3 hours, we can actually see the level of the water. And now we have some sort of introduction to DC voltage measurements. We use some batteries and for DC voltage, and of course we can teach them how to change the scale of the voltmeter, and what happens if they connect the terminals in reverse, and what is negative voltage or positive voltage, etc. And after that, we have, well, I'm trying to make as quick as possible because I don't want Corina to run out of time. This is how we can actually measure the voltage from a plant by using two terminals of the same metal. You have to know that they are the same metal. We don't actually turn our plant into a battery like we do with a potato battery with copper and zinc. Here we have two terminals that are both of stainless steel. One is placed in the ground, and the other is placed on some on the point of the leaf or of the trunk of the tree, and we can record this voltage. And how we can do this, we are going to use time-lapse software again. Here you can see that the voltage is changing because we change the light, or we change some conditions, and of course the voltage needs to stabilize. And you will see that the voltage goes from minus something to almost zero when the lights are off, etc. And this is how you can actually ask your students to make a low-cost data logger. You use webcam time lapse. This is a freeware, totally free software that you can use. You can only use your laptop or your desktop with a webcam, and you can record every a few seconds or every few minutes the screen. You can actually take pictures of the screen of your multimeter, of maybe a thermometer or a humidity meter, and then you put everything. You can make a graph, or you just find the trend, what happens to the voltage when something changes. These are some of, as you can see, some of the pictures taken when we switch the lights off. What creates this voltage is the pH difference between the ground and the tree sap, and because and the driving force for this is transpiration. And the transpiration happens because the evaporation on the leaves creates negative pressure, which might be up to minus 10 bars. It can the water uptake can be as high as 100 meters for some very big trees. Well, I think the rest of the material can be found online, and I hope that some of you, if not all, will contact me and the other authors for more information, and maybe we can collaborate on some project. So, thank you for tonight, and I will pass this to Corina.
Thank you. I was very happy to work in this project because with astronauts, because I adapted one of the analyzer for a tree. In this case, the goals were the same like for an air analyzer, but we work a lot to the SEP module, because here you can see our analyzer for a tree. We called him forest reader. And you can see here it's also with an Arduino, but we choose the sensors very carefully because we needed an air temperature to know if the tree is in good conditions or not. It's a fire in the forest, air humidity, but also the soil humidity, the illuminance, if the tree is in good condition in front of the sun, the carbon dioxide, also the total volatile compounds, organic compounds, and the SEP module. The SEP module, here it's the diagram for this analyzer, but you can find it also in the material in the big project. The SEP module was self-designed sensor, which is composed of two, you see here, two not needles like in Astrino's case. One is a platinum 100 resistant temperature detector, and the other one is a heating element about 7.5 watts, powered at 12 volts. And this SEP module was working, heating a little bit the tree, and the resistant temperature can measure the temperature from time to time, from 30 to 30 minutes. And to work independently, the forest reader power supply is made with a photoelectric cell and a solar charge controller. So this analyzer could be independent many days. And here you can see our students working in the garden, but I think that it's better to see at the end a short video about 3 minutes with them using the analyzer in the garden. Of course, they made also the data transmission within a ESP Wi-Fi module. They created the site and also they made the graphic presentation of the data. We could make many measurements and also correlation and interpretation of the measurements. Here you can see how it's working the SAP module. Here in brown is a graph for the SAP module working in not a good tree, in a die tree, we can see a dry tree, and the interval, the range between the increasing of the temperature and the decreasing at the same temperature is longer than in a normal tree where the sap is working, it's a flow inside the tree and can decrease better the temperature or quickly the temperature. The students presented the project also in Romania, also in Berlin the last week. And thank you very much for your attention. And Daniela, if you can put the video so you can see more about this project. And will be difficult to mount it on the tree, but it's possible. The sensor for the soil humidity. It's cool, it's a little bit surgery in the tree. Generals has also a screen to see something and also transmit the data. Experiment with the light. Thank you again.